Hi, my name is Lorenzo Rota. I work in the Integrated Circuits Group in the Instrumentation Division, and part of my job is developing new detectors here for LCLS2.
Hi, I'm Sandra Beauvarlet. I'm a postdoc here at SLAC, but also at the University of Connecticut, and I work in AMO physics. So I am interested in the interaction of lasers with molecules and atoms, and just looking at what electrons and ions do.
So for this kind of experiment, we need a new type of silicon sensor. This is a special type of low-gain avalanche detectors, in short LGATs. These detectors are typically have been developed for high-energy physics application. However, they don't really work for the kind of experiments that we want to do here at SLS. So one of our colleagues, Julie Siegel, in the Instrumentation Division, has come up with a new type of LGAT that is able to essentially detect low-energy electrons and also soft X-rays. What you see here is the very first prototype that we have developed. We got good performance in our lab when we tested it. Of course, now we want to test with the real thing. We want to test it at SLS. So in a couple of weeks, we will have the first beam time where we really test this detector in the real environment, and only then we will know what is the real performance, and of course, we'll always want to improve on the performance.
What we want to use it for at LCLS is basically to make molecular movies. And how we do this is that there is the molecule, and we send the X-ray that will probe a specific location on the molecule and will blow the molecule apart. And we want to detect the fragments. So either it's the ion part or either it is the electron part. And the advancement that it is right now is that our old detector were working at 120 frames per second. So to make these movies, it needed a lot of time and a lot of frames and everything. And now this new detector is aligned with the LCLS2, which is running at 1 megahertz. So it's like 1 million frames per second. So we will have much more insight into these molecular movies that we're trying to do. So it helps us determine what happens when, for example, in biological processes, if you look at isomerization, if you look at basically how a molecule will change its structure under whatever excitation or some of the thing. So I think it's a very important thing in biology and in pharmacology as well. I told you we could detect basically the fragments when we blow up the molecule, but what I'm working most with is electrons. And so very recently, with the new advances of LCLS, we were able to do some attosecond pump probe, and so we are now able to track electron motion, and so it's very exciting, but it's also very demanding in terms of data acquisition. So with this detector and with the LCLS2, we can basically acquire much more data in a very lower time, in a shorter time, and so it will be really great to have better statistics for our experiments. So we're excited.